Hello, 6th graders. Welcome to Big Ideas Math, 7th grade math, section 8.2, Perimeters of Composite Figures lesson. Pause while you write today's lesson title and number in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is I will be able to use the formulas for area and circumference of a circle to solve problems by completing Big Ideas Math practice with 100% accuracy in multiple attempts. Pause while you copy the following vocabulary word and example exactly as it appears into your math notebook. Our vocabulary word for today is composite figure. A composite figure is a figure that's made up of triangles, squares, rectangles, semicircles, or other two-dimensional figures, and they are put together. So in this example, you have a square and a triangle that are put together to make a trapezoid. So let's get started with example 1, estimating a perimeter using grid paper. So we're going to estimate the perimeter of this arrow, this one right here, and our directions are to count the number of grid square lengths around the arrow. So it says there are 20, but we're going to count them anyway just to make sure the book did it right. So remember, you're counting the length of the line around the figure. So if we start at the end here on one of the points, we've got 2 spaces, 1 and 2, and then we go from there down to the end of the arrow, and I'm sorry, my line is not right on their line, but we count 1, 2, 3, 4, 5, 6, and if there's 6 on that side, there's 6 on this side, and if there's 2 on that side, there's 2 on this side, because this is a symmetrical figure. And so that's 6 here, and 6 here, and 2 here, and 2 here, and then there's 4 on the bottom here, across the back of the arrow. And then what's problematic here is these slanted sides. So if we look at this box, it says estimate the diagonal length to be 1.5 units. So they've sort of exploded that for you, and you can tell that it's longer than 1 unit because it's going diagonally across the box. So if we estimate that to be 1.5, and we count, and there are 1, 2, 3, 4 of those on each side, so it says there are 8, and then 8 times 1.5 is 12, so they did that for us down here. So we've done all this math. 8 plus 8 is 16, plus 4 is 20, plus the 12 is about 32 units. So that's one way to estimate the perimeter using grid paper. We don't always have grid paper, and it's not always a practical thing to do, but sometimes that's a good method and that will work for us. So now looking at example 2, we're going to actually find the perimeter. So this is where it takes a little bit of creativity. We need to look at our figure and see what we can divide it into. And so if we look at this figure on the right, it kind of looks like an ice cream cone turned on its side. But if we look at it a little bit more geometrically, we can see it's a triangle and a semicircle. So we're going to think of what we know about finding the perimeter of a semicircle and the perimeter of a triangle. So it says the distance around the triangular part of the figure is 6 feet plus 8 feet. We don't have to worry about the 10 feet because that's inside. So we're calculating the perimeter of this whole figure, so we're not going to count that part on the triangle part. And then it says the distance around the semicircle is 1/2 the circumference of a circle with this with a diameter of 10 feet. So they give you the 10 feet because that's the diameter of what that circle would be if it were a whole circle. So we go back to the lesson where we learned how to find the perimeter of a circle. And so we've got we divide the circumference by 2. And so remember, the perimeter of a circle is the circumference. So circumference divided by 2 equals pi times the diameter. So 3.14, we estimate pi to be 3.14, and we multiply that by our diameter, which is 10, and we divide that by 2, and we get 15.7, and then we add that to the 14 feet that we already had, and that gives us 29.7 feet.